going to be learning the fifth way to solve a systems of equation. Now, when it's all said and done, I think by the end of class tomorrow, after we get more and more involved and get some more examples under our belt and things like that, I think that you will find that this method is the easiest. I honestly, truly think that this method is easier than substitution. It's easier than elimination. It's by far easier than graphing because nobody likes to graph. Okay? Kramer's rule is way great. Okay? This, I think, you will find, especially when you get to 3x3s. For 3x3 systems, 3 equations, 3 unknowns, this is by far easier than any of those other methods. Okay? Okay? So, today it might be a little confusing for you, but after we practice it a little bit more tomorrow, I think we'll be phenomenal with it. Okay? So, there are two things that we have to talk about, two concepts in math that we have to talk about. The first one is something called the identity. Okay? Now, in terms of numbers, okay, the identity is something that you can multiply a number by and have that not change. Okay? In numbers, there's a multiplicative identity for when you multiply, and there's an additive identity for when you're adding. Okay? You know what they are. You probably just never heard them referred to. Multiplicative identity and additive identity. Okay? When I'm adding, what number do I add that doesn't change? Doesn't change the number that I started with. 0. Right? If I add 0, nothing changes. Okay? 0 is the additive identity. When I'm multiplying, what's the number that I multiply by to not change? 1. 1 is the multiplicative identity. Okay? So, in matrices, we have a matrix identity, or the identity matrix. Okay? We call them matrix I. The reason we call them matrix I is because no matter what the matrix, your other matrix is, the identity matrix is either going to look like for 2x2 that one, for 3x3 this one, the one on the right. For a 4x4, we can continue on with the pattern. And the pattern is, it's a matrix with ones in the main diagonal. Okay? So this right here is the main diagonal. Okay? The criss, if you will, from when we were doing crisscross the last couple of days. Okay? The criss, the big main criss diagonal. Okay? That's the main diagonal. It's got ones on that, and it's got zeros everywhere else. Okay? Now, the cool thing about the identity matrix is that if I multiply the identity matrix, oops, I forgot a T. Oh, wait, no. Identity matrix times any old matrix, I'm going to get the matrix, provided that multiplication can work. You know what I mean? I'm not going to take the 3x3 identity and multiply it by a 2x2 matrix, because that multiplication won't work. It's not possible. Okay? The matching up of the columns of the left one and the rows of the right one has to still be the same. That rule for multiplying still works. Now, here's the not so cool part, the kind of crazy part, is that I can take that same matrix and I can multiply it by the identity on the right side, and I get the same thing. Okay? It's the one time in matrix multiplication that order doesn't matter. So, by hand, what I would like you to do is I would like you to multiply those two matrices to verify that what I'm saying is true. Okay? Because when you take the identity matrix and you multiply it by any old matrix, what should you get? If I take the identity matrix and I multiply it by a matrix, I should get the matrix back, right? Okay? Verify it so that it's so. Fix it. We'll find out here when we go to the video tonight. But
You
never know.
Every day?
No.
It's recording.
Yeah, it's recording, so I'm hoping that this is being inserted. Okay? So, row by column. So that's going to be 1 times 3 plus 0 times negative 2. Row by column is going to be 1 times 4 plus 0 times 5. Row by column is going to be 0 times 3 plus 1 times negative 2. Row 0 times 4 plus 1 times 5 should get me 3 plus 0 is 3. 4 plus 0 is 4. 0 plus negative 2 is negative 2. 0 plus 5 is 5. And those two then are the same. Now, on a calculator, okay, I'll show you how we multiply matrices on a calculator. So the first thing that you're going to have to do is you're going to have to open up a brand new calculator page. Okay? So you go about doing that by hitting the on, double tap the on. I'm a new document kind of a guy. Okay? No, I don't want to save, and I start a brand new calculator page. Okay? Now, we're going to want to multiply our 3 by 3 identity matrix by that matrix. So, how we go about doing that is I first need to insert a 3 by 3 matrix. And that 3 by 3 matrix needs to be the identity. Oops, I missed. Needs to be the identity matrix. Then I need to multiply that by another 3 by 3 matrix. So I need to insert another, whoa, tap the brakes, child. I don't know. Apparently I thought I tabbed out of there. Okay, so make sure that you're out of there, and then insert your 3 by 3 matrix. And that 3 by 3 matrix is going to be -1, 4, 3, 3, 2, oops, -2, 1, 0, 2, 5. Oops, not 55, just 5. And then when you hit enter, up should pop the exact same matrix. Okay. And there it is. Okay. Now, the next concept that we are going to need to talk about is something called the inverse. Okay? The next one then is called an inverse. In terms of numbers, okay, when I multiply a number by its inverse, I get the identity. Okay, so let's take 4 for example. 4's inverse is 1/4. 4 times 1/4 is 1. 1 is the multiplicative identity. Okay? So an inverse multiplies to give the identity. Okay? So a matrix times its inverse gives us the identity. Or an inverse times the matrix gives us the identity. Okay? Now, we're going to focus on that last one because it works. Okay? Here it works without having order. For inverses and identities, it works without having order. But when we're going to use it today, order is going to matter because one side of the equation is going to have the inverse times its matrix, and we're going to make it go away. But the other side is going to have something different. So order matters today in our cases. But if I was just saying, okay, multiplying inverse by a matrix by its matrix, or multiply a matrix by its inverse, you should get the identity back out. Okay? Now, on your calculator, there is a feature that allows you to find the inverses. However, if you have a 2 by 2 matrix, it is faster and less confusing to find the inverse by hand. Okay? Because here is matrix A. Okay? the general matrix 2 by 2 A, B, C, D. Okay? To find the inverse, what we do is we take on the outside, for scalar multiplication, we take the 1 divided by the determinant of A. Well, what's the determinant of A? The determinant of a 2 by 2 matrix is crisscross, makes you want to jump. How do I find the determinant of matrix A? AD minus CB, right? Criss minus cross. Which you could probably do in your head, right? Okay? And then, in this matrix, or in our original matrix, what we do is we switch the main diagonal numbers. So A and D here, okay, this is our main diagonal. We're going to switch those around. So A goes down to the lower right, D goes back to the upper left. And then I'm going to make the other two be the opposite of what they are. I'm going to multiply them both by a -1. And that gives me my inverse. So, let's find the inverse of this matrix. The 2 by 2 matrix, 5, -2, 8, -3. The first thing that I'm going to do is I am going to find the value of matrix A's determinant. So that's going to be 5 times -3 minus 8 times -2. 5 times -3 is -15. 8 times -2 is -16. -15 minus -16 is +1. Okay? So that fraction is just going to go away. Okay? Now then, I need to figure out the matrix part of it. So I switch the main diagonal. So these two get switched. So -3 is up there, 5 is down there. Then I negate the other two. So when it's all said and done, my matrix, my inverse matrix, is the 2 by 2 matrix, -3, 2, -8, 5. Okay? Again, once you get more practice with that, that will be faster than doing it on the calculator.
You always get one with the.
No.
So what do you do if you don't get one?
Then you've got a fraction up front.
So then you use the fraction all the time.
Yep.
But the inside of matrix stays the same.
Yep. Okay? Now, let me show you how to do that on the calculator. Okay? So on the calculator, in order to do that, what we're going to do is we are first going to create for us a 2 by 2 matrix. Now I should have wrote that one down as to what it was. 5, -2, 8, -3. Okay? We know from our last problem that this answer is going to be -3, 2, -8, 5. Okay? The same one as we just did. Okay? Same one down here. So that's going to be our answer. Okay? So on the calculator, what I do then is I type in that matrix. Okay? And then I take that matrix and I raise it to the power, let's raise it to the power, okay, of -1. And when I hit enter, it will automatically calculate for me that inverse. Oops.
When you say it switches, the 8 and -2 don't switch.
They didn't switch.
Why aren't they supposed to?
They're supposed to become negatives of each other on those. Remember? Switch the main diagonal, negate the other two. They don't change, they just negate. Okay? Alright, let's put it to work. Okay? If I were to go about solving this system, okay, I would probably multiply this left equation by -2, right? Okay, so -2x minus 6y equals +4. And then I'm going to add that to my other equation. 2x plus 7y equals -6. And that's going to give me y equals -2. Right? Okay. If I plug -2 back into this equation, then I would get x plus -6 equals -2, so then x would be 4. Right? So the solution to that system is the point 4, -2. Agree? Everybody good with that? Okay? So we know that to be true. Okay? So it has a solution there. 4 plus -6 is -2. 8 plus -14 is -6. It checks out. It's all good. Okay? Now, let's solve that system using matrices. Okay? So the first thing that I have to do is it's an hour class, he's got a conflict with. Okay? Okay? The first thing that I have to do is I need to write that equation in what I'll call now stacked form. Okay? And it's all got to line up. X's need to line up, Y's need to line up, equal signs need to line up, numbers need to line up. Okay? Called stacked form, where everything is stacked on top of one another. Okay? Then, what I am going to do is I am going to put that equation into the matrix form of it. Okay? Now, the matrix form of it has the first 2 by 2 matrix is the coefficients in stacked order. Bouncing today. Okay? It's the coefficients written in stacked order. 1, 3, 2, 7. 1, 3, 2, 7. Written out in stacked order. Then I'm going to write what's called the variable matrix. If it's a 2 system or 2 by 2, 2 equations, 2 unknowns, it's x then y. A 2 by 1 matrix x, y. If it's 3 equations, 3 unknowns, it's x, y, and z. Okay? I write the variable matrix. Okay? Then I write equals, and then that's going to equal what I call the numbers matrix. Everybody with me so far? Okay. Now, side note on this, if I were to call this matrix C, and I multiply matrix C by my variable equation, that's then going to equal my numbers. Right? Ideally, we would want to get rid of matrix C from the left side of this equation. Right? And we want to get rid of it. We want to get our variables by itself. So in order to do that, since we can't divide matrices, but we can multiply by inverses, I am going to multiply on the left side by the inverse of matrix C. Now, from a couple of minutes ago, an inverse times its original matrix does what? What does that make? Makes the identity matrix. From a few more minutes ago, the identity matrix times any matrix is just that matrix, right? So really, what happens on this left side? What gets left over? Just your variable matrix. Okay? You've effectively divided by C. Now, what's the golden rule of algebra? What do you got? What I do on one side, I got to do to the other. So if I multiply the left side by the inverse of C, what do I have to do on the right side? Multiply by the inverse of C. Now C is a matrix, right? So how do I have to, or how can I multiply by C on the right side? I have to go in order, right? Because order matters. Okay? So if I multiply by the inverse of C on the left side of the left side, what am I going to have? Where am I going to multiply by the inverse of C on the right side? No. On the left side of the right side. Oops, this was numbers. Numbers! Not X and Y. Okay. So then over here, this is going to be inverse of C times my number matrix. Okay. And that, then, when I do that, now I got to go find it. Way down here. Just get rid of this. Get rid of this. Get rid of the shade. It's way. Oh, maybe I got rid of it. Okay, yeah. So, and then that then is going to give me the matrix XY, and that's going to equal 2 numbers in this particular case. Okay? And then X should be equal to 4. When we do this, this number up here should be 4, and the bottom number should be negative 2, because X is negative 4, the bottom number is negative 2. Okay? In short, what we're doing to solve this matrix equation, and trust me, I went through Colby to go to Mosinee for this explanation. Okay? In short, all you've got to do is find the inverse of your coefficients matrix and multiply it on the left side by your numbers matrix. That's it. That's all you got to do. Okay? So to solve this matrix using inverse matrices, the first thing that we need to do then is we should find the inverse of my coefficient matrix, right? So that's going to be 1 over Chris minus Cross, right? So that's going to be 1 times 7 minus 2 times 3. Then I flip the main diagonals, correct? So that becomes 7 up there, 1 down there. And I negate the other 2. One times 7 is 7. 2 times 3 is 6. 7 minus 6 is 1. So the inverse here is just 7, negative 3, negative 2, and 1. So, if I multiply on the left side by the inverse, it would look like this. Right? Because if I multiply on the left side over here by the inverse, I've got to multiply the right side on the left side by the inverse. Agree? What I've done to one side, I've done to the other side. I've still followed the golden rule of algebra. Correct? Now we know that these two right here are what? They're inverses. So what happens to them? They cancel each other out. So that leaves me with x times y, or excuse me, the matrix xy. And what can I do on the right side? We can do that multiplication. 7 times negative 2 plus negative 3 times negative 6. Negative 2 times negative 2 plus 1 times negative 6. Negative 14 plus 18 is 4. 4 minus 6 is negative 2. So this solution then would be 4, comma, negative 2. Again, I went through Colby to get to Mosinee. It was your first time, Wesley. Okay? When you were born, did you run a marathon right away?
Yep.
No. Okay? It took you a little bit of process to learn how to walk first, right? Okay? Now, on the calculator, let me show you something that makes it, as Wesley said, easy. Okay? So, here is, on the sideboard here, I've got the original matrix equation, right? Okay? I know, because I've practiced this once or twice or 1,000 times, I know that I've got to take the inverse of that one and multiply it by that one, right? So on my calculator, I can go with a 2 by 2 matrix, 1, 3, 2, 7, and I need to take the inverse of that times a 2 by 1 matrix, negative 2, negative 6. Okay? Same problem, I just did it in, how long did it take me to type that in? Less than a minute? Okay? So do you see, Wesley, how it makes things a little simpler? If you know the background behind it, you can go right to the answer. Can't do that with substitution, can't do that with elimination, can't do that with Kramer. Can't even do it with graphing. Okay? Okay? As long as you set it up right, you can go right to the answer. Okay? And I could do this on pencil and paper too. I can go right to the answer now that we've walked through how to set up each problem. Okay? All right? So, down here, what's that? Okay. There it is. Okay. This top one, you can do a few of the problems, but we'll get more practice tomorrow on this. So the top one there is due on Monday. If you wanted to start thinking about Tuesday's test, there is the bottom one. That's our chapter review assignment, and it will be due on Tuesday. Easiest of the